Welcome again, guys. Our rest of this class is being soon. Please join. And within this period, I am drawing the next. You can see this is your process. This is your process. Let's process. This is your output. This is your output. Okay. Look, this is process and this is input channel, this is output, but this is if your your feedback, because it is measuring your output data. Okay, so this is a feedback control action. Feedback control. Okay, but here you can see in same, just like same, if this is a process, some disturbance is coming, some disturbance is coming, and this is output. It is measuring only the disturbance, not the process output. Okay, or maybe some graphical representation is there. So this operator, input says output. Okay, so this is disturbance. So guys, this is feed forward control action. You can see this is feed forward control action. Okay, so you can see the in the feed forward control action, only the operator, or you may say it's the controller, it can measure only the disturbance. So as per the disturbance, it this controller or the operator can control the input only. But in your feedback control action, you can see the operator, or it may be operator or controller. Okay, so it it is taking the measurement of output, and then it will control the input. So the accuracy level for the feedback control action is very much high, but the accuracy level in the feedback feed forward control action is quite less. But why we are applying on, why we are interested on this feedback feed forward control action? You can see the disturbance is coming. This is called disturbance. Actually, the input level or the set point level or the set point and is varying. Say, I want, sometimes I want 60-degree temperature. This is our set point. Sometimes we require 70-degree centigrade. Sometimes we need this 80-degree centigrade. This like the disturbance. So whenever set point or requirement is changing, then we can say this is our disturbance. So whenever say this is a steam flow, just like a steam flow is going on, and this is a process for a boiler, and when steam is flowing through this, say I need only 80-degree centigrade. This is our set point value. Okay, 80-degree centigrade. But now the process value is 60-degree centigrade. So I need at least 20-degree rise of this temperature. So I want to flow the steam through this boiler, so that the water content in this boiler, it will reach up to the 80-degree centigrade. Whenever it will reach 75, 78, then I will select no, we need to control this. We need to control this because whenever 60 degrees temperature was the as a process value, then we need some steam. But whenever 70-degree temperature process value reach, then we don't need much amount of this amount of steam. Whenever it is reached at least 78-degree centigrade, then we no need of this much this steam. So gradually we decrease this. But what happens at that moment? The process value increase or some disturbance is coming, so that this process value will increase up to the 90-degree centigrade. Say I need 90 degrees. Then again we have to operate it. Okay. So in this feed forward control action, and we are measuring or we are concerned with the set point value, because this set point value is changing, or it may some way that there is some x amount of liter, say 100 liter or water is there. You need to reach the 80-degree centigrade. So you are putting some flow, and that is 80% flow rate. You are This is your flow rate of this steam. So it will take uh, at least 1 hours to reach this 80-degree centigrade. So after 50 minutes, you can see that is whenever you 80% applied, and within this 15 minutes it will reach at least 78-degree centigrade. But this 100 liter was fixed. But now what is the disturbance? Say again 50 liter water will be introduced in this process. So what happens? Your temperature automatically decrease up to this 78 to 60 degree. So again you have to increase, or you have to change your or 80% of the flow rate of the steam, so that we can reach the 80-degree centigrade at least within few minutes. So again you have to change this. So in this way, feed forward control action is working, because we are observing the disturbance. So what happens? We need a particular database. Means you can see if it is required, some particular database is required for this feed forward control action. Otherwise, as your control action will just going to ruin, because you don't know how much amount of uh, steam, how much amount of flow is required. Just like your bread, just like in bread toaster. Say if you don't know, you want to toast your bread. This is one type of open loop control system. You don't know what amount of temperature and what is the specific time. Say first time you apply 100 degrees centigrade for 5 seconds. Okay, then you see that after completion of this, because this is a on off, this is a open loop. So after 5 seconds, you can see that is your bread became burned. So next time you apply 100 degree centigrade and apply for 3 seconds, then you can see your bread is just raw bread is there because it is not baked. And again you apply 100 degree centigrade for 4 seconds, then you can say yes, this is right. So you need some database is so that you can apply this feed forward system. Okay, but this is a open loop system, you don't know what happens, but this is a one type of closed loop system, but where this closed loop system is depends on, you can say this is closed loop system because this operator is working over there. And and this picture is just for your understanding, better convenience. Okay, uh, but this is controller. Okay, but this is dealing with this disturbance. And after seeing this, if it is started its feed in previous time. Say if we know that 100 liter is there, 100 liter is there, and I need 60 minutes I have, and I need the temperature is this is time, and this is quantity. So 100 liters, 60 minutes, then temperatures are I and this is the set point value. This is 100 degree centigrade. So I need to open 80% of steam flow for 100 minutes. If there is a 100 liter is there, I have the 60 minutes, but temperature is 110 degree centigrade. Then I need to, within this period, I need to this 90% steam flow. Okay, in this way there is so many databases there. Actually this is a just like a database or rule base, or you may say this is a experience. In general, if this operator is there, manual intervention is there, human intervention is there, then we say this is the experience. But if it if it will applied in this controller, then we have to apply this type of database. So you have set this program, then it will going on. But within this, if there is a disturbance is coming, if disturbance means this 100 liter increased up to this 110 liter, then this database will not working. Okay, then you have to apply some changing. But that's why your accuracy point is very less than this feedback control system. Okay, so I think you can understand and what is the feed forward and what is the feedback control system. Okay, so let's going for the details on this is feed forward control action. Okay, so you have to write down some point, that is conventional feedback control loop can never achieve perfect control. Okay, as the disturbance occurred and changes the set point value. Okay, so forward a feed forward control configuration, measure the disturbance directly, and takes control action to eliminate its impact on the process output. Okay, so if I have the total rule base, perfect rule base, perfect experience, then this feed forward control action is very accurate. Okay, just like your or bread toasting or any other say gardening sprinkler in gardening, etc. But if I have no rule base or no experience data, then it will be difficult to reach the accuracy point, high accuracy point. Okay, the information concerning this rule base means information concerning one or more conditions that might disturb the control variable converted into corrective action to minimize deviation of controller of deviation of controlled variable or controller. Okay, controlled variable. Okay, and the feedback controller, you can see this is feed forward controller have the theoretical potential for perfect control. Okay, say what is the block diagram of this feed forward control action? Look, you can see this. This is controller. This is controller. Okay, this is process. Process. This is disturbance. Okay, then this controller is controlling the input. Okay, then this controller that is called Okay, and this is controlled output. Okay, so this is the main difference between this is feed forward control and feedback control. In feed, look, if you draw the block diagram of feedback control system, then you have seen this is comparator, this is process, this is output, and output is taken, this is feedback, this is input, this is error signal, this is process, and this is feedback. So you can see there is a control over this input whenever output is changing, or we are saying that this is the set point value and this is the process value. Whenever it is reach this set point value, then it will not control. But here this feedback control, feed forward control system, the disturbance is measured, and this disturbance is whenever this disturbance is measured, then controller are controlled on the manipulated variable. Okay, and it never taken care on this controlled output. No relation between controlled output. But here in this is also a summer point, and on off valve is there. Whenever on off valve or switch is there, then it is called controller, and this is taken care of the output, and that's why called this is called feedback control system. In this system, output is, if there is some disturbance, output always varying. So we never reach the the set point and or the accuracy level. Okay, but in this feed forward control system, if I have the perfect information, say this is the 100 liter quantity of water, I need 100 degrees centigrade need the temperature, and I have the 60-minute time. So I know that if I 80% steam flow is allowed, then it will easily reach, or it may be reached is the after 60 minutes at 100 degree centigrade. So we apply this rule base, then it will reach this is set point value. Okay, because we have measured it. So this is called a rule base or the experienced. Okay, and in this way we are applying this feed forward control action. But where we are taking interest on this forward control action when this disturbance or the process is changing, then this control action is very much efficient. But whenever our we don't have any information, we don't have any rule base, then we are applying this feedback control system, because we don't know how much amount of stream flow is required at for 100 degree centigrade within this time. Okay, because your time is also factor is there, but here is we don't know. No, it may be 60 minute in case if we apply this is 80%, because here input variable or manipulated variable is fixed. Okay, it is just on or off. Say now 80% is going on. So okay, 80% is going on, 80% is going on. Whenever it is 100, say 80% is going on, that is set point value, and our process value is now this is 70 degree centigrade, 75 degree centigrade, 80% is going on, 77 degree centigrade, 80% is going on, a 78 degree centigrade, 80% steam flow is going on, 79 degree centigrade, and that is going on. And but input variable is same. Whenever 99% is reached, 99 degree centigrade is reached, then also 80% is 80% stream flow is going on. Whenever 100 degree centigrade is reached, when then this controller or comparator comparate, yes, I have reached this 100 degree centigrade as the set point value, then only it off this input, say 80% to the 0%. Okay, but within this closing point, it the process value may be 100 at 5 degrees centigrade. So the accuracy level, reaching of accuracy level is uh, quite difficult for this feedback control system. But in feed forward control system, this is feed forward control system, you can see, if I know this experience or if I know the information, then easily I can apply over this. Then easily after 60 minutes, because after so many experiments, it will reach this point. Okay. So then it will just reach this position easily, so that after 60 minutes it will get 100 degrees centigrade, then it will stop this process. Okay, so in this way feed forward control system action is working on. Now we are going for another, for a perfect control system, so that you can understand this thing. Just like this boiler, this is, this type of boiler is working on your normal food industries, hospital industries, medical industries, where some steam and hot water are required. So there is some heat exchanger are there. This is called heat exchanger. Okay. Okay. Out. And this is input. Okay.